Hey everyone, it's Mr. Dubrow, and just want to make this short video for you, doing a quick review of Unit 3, Accelerated Motion. So we're going to start off by just taking a quick look at the graphs of motion that we've been talking about. We've had three main graphs we've been talking about. We have been looking at the graphs of position versus time, velocity versus time, and acceleration versus time. Okay? And in our accelerated motion model, we start with the idea that if acceleration is constant, we're going to have a horizontal line here. That means that the velocity is going to be linearly increasing, so it's going to start at some initial value and increase in a straight line. So in other words, v will be proportional to t to the first power. Here a is proportional to t to the 0 power. And so that means that our x versus t graph is going to be something like this, where x is proportional to t squared. Okay, now we also talked about the equations of motion, which tie into these graphs. And as a matter of fact, we can write the equation of this line. Instead of writing y equals mx plus b, we can write v final equals v initial plus acceleration times time. And then, of course, the acceleration is the slope of this velocity graph. So that's the slope. And this is our velocity equation. Okay? So one of the big takeaways in this unit is that the equations in the graphs are very closely related. We also want to remember that we can calculate two types of velocity from the position graph. If we pick 2 points on the graph and connect them with the straight line, that represents the displacement divided by the time. And we know that delta x over delta t is what we call the average velocity. So that's the slope of 2 points on the graph. However, if we look at the instantaneous velocity, that's the slope at one particular time. And I'll just redraw that graph here. And if I pick a time such as this, so x versus t, the instantaneous velocity is the slope of the tangent line. Okay, so those are important. And aside from these basic equations here, the definition of average velocity, the velocity equation, and the definition of acceleration, we had a couple of other important equations in this unit. We had two equations that helped us find the displacement. We had the displacement equation, delta x equals v initial times t plus 1/2 times acceleration times time squared. And remember that this equation is essentially the equation of this parabola. And then we also rewrote this in terms of average speed to say that delta x was v initial plus v final over 2 times the time. So this term right here, vi plus vf over 2, is another way of writing v average, and then that's times time. Okay, and then finally, we had what we call the forgotten equation, which is useful if you don't have the time, and that's v final squared equals v initial squared plus 2 times the acceleration times the displacement. So these are really all of the major concepts in this unit. I just want you to keep in mind what we've talked about, that not only can we find the acceleration by taking the slope of the velocity graph, but as you hopefully remember, we can also take the area of the velocity graph in order to find the displacement. So I'll just get rid of this and remind you that if we were to find the area under the curve, that this area represents displacement. Okay, so I think that's about it. Feel free to email if you have any questions, and good luck with your studying.